Hi all, this is lecture 19. We're in section 5.4 on logarithmic functions. Okay, so in section 5.2 and 5.3, we started talking about exponential functions, right? So exponential functions where you have a to some power, right? And then natural logarithms where that a is actually e, okay? So what we're going to do now, jumped around here, sorry about that. Now we're going to talk about logarithmic functions, and logarithmic functions are the inverse functions for exponentials. So just like add and subtract are inverse operations, multiply and divide are inverse operations, square and square root, here exponentials and logarithms undo one another, okay? And that's kind of how we define it actually. So for our definition for a logarithmic function with base a is a function f defined by the following. So y equals the log base a of x if and only if. And if and only if just means that the relationship goes both ways. Let me try that again. If and only if. So that's just like an arrow, like a two-way street. So if my y equals the log of a to the x, then that implies that x equals a, because that's our base, to the y. Okay, so it kind of swaps the positions. Okay. And so the way we think about it, if we have y equals the log base a of x, then what we have really, when we rearrange, the y represents the exponent, so it's log. Then we have the base is down here, right? Whatever your base is going to be. And what comes after is the answer, right? The log of whatever we call this the argument. Whatever you're taking the logarithm of is the argument. So the log base answer is equal to the exponent. So a logarithm is really kind of an exponent, okay? And so our if and only if just means both ways. So I can write it as a log, and then I can switch it to an exponential form, or I can start with an exponential form, and I can switch it back to the log. So it just means I can go both directions, okay? Now, the two special cases of logarithms are what's called the common logarithm and the natural logarithm. So the common logarithm is just your log that's base 10, okay? So your common logarithm is base 10. And so what we do is we just drop the 10. So if you see something that just says log of x and there's no base down here, right? There's nothing right here to tell you what the base is. We assume that that's log base 10, okay? And that's for every x greater than 0, right? Okay. You actually cannot take the log of something that's negative or 0. If you try putting that into your calculator, it's going to tell you it's an error, okay? It just doesn't make sense. And that's because when you take, right, they're inverse functions. So if this represents the exponents, so x represents the answer to an exponential, and those are never negative and they're never 0, okay? Now, the natural logarithm is the same kind of thing. We use an ln to represent that. So I'm going to write it like this, ln of x. And that's just log-based e, okay? Just our natural exponential function was e to the x. So our natural logarithm function is log-based e, okay? And of course, that's again for every x greater than 0, okay? So you take the ln of 0, your calculator is going to say, nope, doesn't work, okay? So the two things we want to be able to do here is we want to be able to convert between my two different formats, and we want to be able to solve, okay? So here we go. We're going to change to exponential form. So we have log 5 of 6 is equal to x plus 2. So remember that this 5 is your base, the 6 is your answer, and what's over here is your exponent. So if I'm going to change that, this is going to become the base is 5, the exponent is the x plus 2, and the answer is 6. Okay. Now, I don't want to actually solve this and find the x's because that's way too hard for us right now, right? We can't actually do that because the only way we could do that if the bases were the same. So all we want to do is change it till it looks like the exponential form. Okay, now here's another one. We have log of x equals 3. Now this time we're missing the base, and that tells me that my base is equal to 10. Okay. Again, whatever comes after the log is your answer to the exponential form. And this one right here, what's currently the answer in the log form, is your exponent. And so that means I'm going to have a base of 10. I'm going to have an exponent of 3. And that's equal to my answer, which is x. Okay, so that's how we change it to exponential form. So in this case, x is equal to 10 cubed, or 1,000. Okay, same thing with natural logs, right? So natural log, when you see the natural log, this tells you that the base is equal to e. What you're taking the natural log of is your answer. And what's over here is your exponent. So that when we flip it, we want base first, so e. Exponent comes next, 7. And it's equal to whatever I said the answer was, so 2x minus 1. Okay, and that's my exponential form, right? So a natural logarithm becomes a natural exponential form. Okay. All right, now we want to go the other way. Now we're going to give you exponential form, and we want the logarithm. So same kind of thing. I have this already set up. So my base is the 4. My exponent is up there, and this is my answer. So that when we switch it to log form, we want the log-based 4 of the answer, so the 16 comes next, and it's equal to the exponent, so x plus 2. Okay. Now, why would you do that? Well, because in this case, now I could subtract 2 from both sides, and I know what x is, so I could solve for x quickly on this one. Okay, but that's how we put it back together. Here we go with another one. This time our base is 10. Okay, so we know that this is our base, so that when I write down my logarithmic form, I don't have to write a base, right? Because that's our common log, is you can write log without a number. I have 3 as my exponent. And this is my answer. So when I put this back into log form, I want log base 10. So you could write it, but you don't have to. Then next comes the answer. So that's the x plus 5. And more than one term there, so I'm going to go ahead and put it in parentheses. And that's equal to the exponent, which is 3. Okay, so we flip it around in that way. And lastly, one with an e in it. So we're going to change this one to logarithmic form as well. So we've got base e, which tells me I'm going to use a natural log as opposed to a regular log. We've got our exponent, and we have our answer. And remember, our log is always of the following form. It's log base, but this one is natural, so we're going ln. So I don't have to write a base. Then I get the answer next. So 4x is equal to the exponent, which is equal to x. Okay. All right, and then the last thing we want to do is solve, okay? Now, in order, this is kind of just like we did with our exponents. So in order for when we had exponential functions to be able to solve, we had to have the same base, right? And then we could set the exponents equal to one another. Well, the same kind of thing here happens. As long as I have the log with the same base on both sides, then what I'm going to do is I'm going to set the two arguments equal to each other. Again, the argument is what you're taking the log of, so that's what's in each parentheses. So in this case, all I'm going to do is set those two pieces equal to 0. So I'm going to have x plus 4 from the one on the left. It's going to have to be equal to 1 minus x. And then whatever equation I get, I'm going to go ahead and solve. So let's add an x to both sides. And let's subtract our 4 from both sides. And that's going to give me 2x on the left and negative 3 on the right. And I can get my x by itself if I divide by 2. So we'll have negative 3 halves here. Okay. And then you probably want to check to make sure it works. You could plug in your negative 3 halves there and add 4. And that's going to give you a positive number, which is good. Well, that's what we want. And 1 minus a negative is also going to give us a positive number, which is what we want. Because remember, you can't take logs of negative numbers. Same is true if we have ln's, right? So as long as it matches, we can go ahead and kind of just set the inside piece either equal to each other. So I have 2 natural logs here. So now I can just set their insides equal. So 2x minus 7 is going to be equal to 5x. And then we can go ahead and solve. So I'm going to go ahead and subtract 2x from both sides. That's going to give me negative 7 and 3x. And then divide by 3. And that's going to give me x equals negative 7/3. And that's it.